Example 2, factor x to the fourth minus 4x squared minus 5 completely over rationals, real, and complex. I'll show you what the difference between them is. First of all, it might be difficult to factor a fourth degree polynomial, even though it is a trinomial. So you might want to make a substitution. Look at the variable in your middle term, that's x squared. Let's make that equal to a. So let a equal x squared. And then a squared is x to the fourth. So I can rewrite this as a squared minus 4a minus 5. And that's pretty easy to factor. So I'll say, all right, I need factors of negative 5 that add up to negative 4. So that's negative 5 and positive 1. But a stands for x squared minus 5 and x squared plus 1. Alright, now to find the fully factored form, I need to find all the zeros for each of the factors. So when is x squared minus 5 equal to 0? It's where x squared is equal to 5, so where x is plus or minus root 5. So this parentheses will factor further into x minus root 5 times x plus root 5. The second parentheses, x squared plus 1, let's find the zeros for that. It's where x squared is negative 1, so where x is plus or minus square root of negative 1, which is I. So this factors into x plus I and x minus I. So let's go back to what the question has asked us. Factor it completely over rationals. This is A, because all these numbers are rational numbers. This is factored completely over complex, because there's irrational numbers and there's complex numbers, so that's C. If we wanted to go one step less to factored over reals, root 5 and negative root 5 are real numbers, so I like those two factors. But these two are complex numbers, which is not a real number, so I need to rewrite this as x squared plus 1, which is where I got those two zeros from. So A is here, all rational numbers. B is here. I found the irrational roots. And C is when I found it's a fourth degree function and I found 4 factors, and every single factor is a linear factor.